So good morning students. So as we have studied in class 11 functions, relation and function. Now today we are going to start functions class 12 chapter 1, where we are going to deal first about functions and types of functions. Okay. So first the thing is, as in class 11 we have studied, function can be of two types. Like functions can be one and many one. One more option is there, which is one many. One many are actually relations. When we talk about functions, functions can be one functions and many one functions. Okay. Now let us recall. This side is called the domain of the function, and this is the range of the function or codomain. Similarly, this is called the domain. The first set is called the domain, and the second set is called the range of the function. Now, if we talk about functions, okay, function works on two sets. Obviously, like first is our input set, as we said in class 11. This is our input set, and after applying the function works like a machine in a factory. If we put some input, okay, we will get some output. Let us take one example. If I take a function from natural number to natural number, okay, we can see natural number to natural number, means this is my domain and this is my codomain. So it is from n to n. Now if the function, like I told, like it is a like factory, okay, if you give some input you will get some output. So let the function be fx equal to 2x. So in my domain, this one point will go to which point? Like if you put f1, the point will go to 2, because 2 into 1 is 2. Similarly, for the point 2, the image will be 4. Correct? These are for the image of the function. Next, for 3 it will be 6. So like this we will get all the corresponding images. For 1, 2, 2, 4, 3, 6 and corresponding we will proceed. So now, as we know from class 11 like this, so functions basically has one means for every element in the domain there exists a unique image in the codomain. Codomain or range, there is a difference between codomain and range that I will explain you. Okay. In class 11 also we have discussed more about this domain, range, codomain. Okay. So now like A is going to 1, B is going to 2 and C is going to 3. Okay. So we can see the function is 1 means 1 is going to one thing. So it is a 1 function. Correct? Similarly, it is many one. Many one means like A is going to 1. Correct? Okay. But you can see B, C and D. These three are going to only a single element, that is 2. So this type is called as many one and this is called as 1. And try to understand as a know that one many is not a function. Rather than it will be a relation. As studied in class 11, it will be a relation. Now, this is about functions. The functions are basically working upon two sets, two non-zero sets, okay, such that when we put the domain in the function, we get the corresponding image in the codomain on the right side. So like this is 1. So functions are of two types. It can be 1 or many one. Okay. Now let us proceed toward the next thing, that is what is injective functions. Injective property, injective function. When we talk about class 12, this is the most important and conceptual topic. So first thing is injective. Injective and surjective. These two things we are going to study today. Injective means, okay, if we are having a function f denoted by small f from a set A to set B. These are two sets. Okay. So now when we will call this function as injective? When corresponding any one element of this set will go to a single image, means a unique image in the set B. This is set A and B. then every element in the set A has a unique image in the set B, then this type of function is called 1-1 function or injective function. So whatever we have studied here, 1-1, that is the thing also known as injective function. So we can also say it as 1-1. So this is the property known as injectivity property, okay, or injective function. So if a function follows this property, then it is an injective function. Correct? Let us take some examples of injective function. Yes. I think I have given one fx equal to 2x. Okay, so let us see. So fx equal to 2x. When the function is from natural number to natural, we have to always denote from which domain to which range or which codomain we are doing the function. So fx equal to 2x. Do you think it is 1-1? Yes, it will be 1-1. How? Let us see. 1 will go to 2. 2 will go to 4. 3 will go to 6. So yes, obviously it is 1-1 because every element is going to a unique element in our domain set. Sorry, codomain set. So this is called injective functions. Many more examples are there. Let us take one more example. From function n to n. Again, domain is n. Means will be our input function is n, and our output will be also in n, natural number. So let us take fx equal to x square. If I take x square, so now our one element, 2, 3, 4, many are there. Okay, so 1 will go to 1. Can you say 2? So 2 square is 4. So 2 will go to 4, 3 will go to 9, 4 will go to 16. So you can say again it is 1-1. Yes or no? So these functions are 1-1 functions. Now let us take one example which is not 1-1. Okay, let us see one function which is not 1-1. Okay, so I'm going to rub this side. Now if I see that it is not injective, if I say that not injective function, I am going to give example of a function which is not injective. Okay, 1-1 means it is not 1-1. So let us see one example from, I am taking f from z. Z means set of integers to natural. And the function is defined by fx equal to x square. Now let us see it is 1-1 or not. As you can see, for -1, the image will be 1. Similarly, for 1, the image will be 1. So you can see now it is not 1-1 because now it is proceeding to many 1 function. Yes or no? So like this, many examples are there which is not 1-1 function. So we got the injective property. When there is for every element of domain, we get a unique element in the codomain set, then the function is 1-1 or injective. They are same. Now the next thing, after injective we will proceed to surjective. These two are very important things. Now let us go to surjective. So I am going to rub this side. Okay. So injective property is okay, I think. So I am going to rub this side. As we have done these things, let us proceed this side. So now let us proceed with the surjective property. Okay. Surjection. Now as surjection is known, okay, so surjective property, it is also called onto functions. So you have to understand and remember the names surjective and injective. Now surjective. And what do you mean by surjective functions? Okay. Now if there is a function from set A to set B, remember domain, codomain. Now if this is our set A and B, correct? Now like A is going to 1, very good. Then B is going to 2, like this we can proceed. C is going to 3. If in codomain set some elements are left out, like D is there, means D is having, 4. 4 is having no pre-image. This side I am saying 1 is the image of A, but here I will say A is the pre-image of 1. So let me write here. This is 1 is the image of A. Okay, but here I will say A is the pre-image of 1. You are getting? So A is the pre-image of 1. But for the element 4, there is no pre-image. Means this codomain, some elements, at least one element is left out. If any one element is left out, then it is not surjective. If all the elements are mapped, if all the elements here are having pre-image, if I say now, this D is also going to 4, E is also going to 4, okay, no problem, because none of the elements are left out. If any one element is left out, then it is not surjective. All the elements must have a pre-image in the set A. Correct? So for 1, 1, again I am telling, for 1, 1, every element in the domain has a unique image in the set B. So this is 1, 1, very simple, 1, 2, 1, by the name you can understand. For the onto, none of the elements in the codomain must be left out. If any single element is left out, means it is not surjective. Correct? So all the elements of codomain, I can say a ranges, because here codomain and range will be same according to class 11. So all elements of codomain has a pre-image in domain set. Correct? Now let us take some examples which are surjective. Okay, surjective examples. So I'm going to rub. Let us write this side. So surjective, let us take some examples. I'm going to rub this side. Okay. Now surjective. Okay, how surjective will work? So surjection. Surjective or surjection. Let us take an example. F from, I am taking n to n. Okay, and the function is defined by fx equal to x. Very simple. Okay, it is called identity function. It is called identity function. Okay, identity function. So now, if the function is from n to n, 1 will go to fx, f1 equal to 1, 2 will go to 2, 3 will go to 3. You know, if I proceed, none of the elements will be left out in the codomain set. So this is the example of a surjective function. So the function is surjective. So I can say the function is surjective. Yes or no? Yes, you can say it is surjective. Now let us take some examples where the function is not surjective. Okay. Now I am taking one more example. F is equal to n to n. Okay. F is from again n to n. And again defined by fx equal to x square. You remember we have taken this earlier also. So now n to n, remember natural number to natural number. So 1 will go to 1, 2 will go to 4. Now have you seen one thing? 2 and 3 is left out here. Yes or no? Yes, 2, 3 is here. 2 and 3. Again 3 is going to directly 9. What about 5, 6, 7, 8? You can see many elements are left out in the codomain which are having no pre-image in the domain set. Means this function is not surjective. You will say it is not surjective. So like this, there are two types, was 1-1 functions and onto functions, or injective functions and surjective function. Injective means 1-to-1, surjective means none of the elements in the codomain must be left out. So we can see very easily that 1-1 and onto. This is the first concept of class 12 which will be very helpful for you. Okay. So surjection is done. Okay. Now I am going to tell one more thing after injective and surjective is done. If a function is both injective and surjective, if the function is both injective and surjective, then what happens? Then the function is said to be a bijective function. This is very important concept, bijective function. So this term you have to remember, and it will be very useful for your chapter 2, inverse trigonometric functions, where we will deal with the bijective functions. Okay. So whenever a function is 1, 1 and onto, then the function is bijective. Injective, surjective together combines and form bijective function. And if a function is bijective, then only its inverse exists. Inverse of a function that we will study in the next class. So there are many things about this. Like if I say function from R to R, real number, R to R, real number to real number, and the function is fx equal to sin x. Now you know the domain and range of R, means the sin x function. You know, sin cannot exceed 1 and cannot be less than -1. If you see the graph of sine, in class 11 we have seen graph of sine, cos, tan. If you see graph of sine, you will see very one prominent thing that sine never, if I draw the graph of sine, okay, this will be always 1, means it cannot cross 1, sine cannot cross the value of 1. Similarly, the lowest value is -1. So if I put anything on the real number, like sine, this function is sine, I told you sine. What is sine 0? 0. 0 will go to 0. Correct? Now if I tell you, what is sine pi by 4? If I take pi by 4 here, it will take 1 by root 2. Correct? Sorry, sine pi by 4, 1 by root 2. Then sine, if I take pi by 6, sine 30 is 1 by 2. Like this we will go on. Correct? So you can see this function is not 1, 1 or not. Is it 1, 1? It is not 1, 1. Because if I take many values like sine n pi, all the multiples of pi will go to 0. Okay, sine pi is 0, sine 2 pi is 0, sine 3 pi is 0, so 1, 1, it is not 1, 1. Similarly, many elements will be left out because the highest value can be 1, the lowest value can be -1. What about the element after 1 and what about the element less than -1? So there are many elements which are left out in the codomain. So this function is not 1, 1. Yes or no? It is not 1, 1 now and it is not on 2. So it is not bijective. Correct? But if I say one more function, let us see one example of bijective function. If I take fx equal to x, a simple function, identity function from n to n, natural number to natural number, 1 will go to 1, 2 will go to 2, 3 will go to 3. Is it 1, 1? Yes. Is it on 2? Yes. Why? None of the element in the code